All right, let's jump right in. If you've ever dug into how machines send precise rotational info, you've probably run into standard synchros. Well, today we're going to meet some of their really interesting cousins, each one a specialist with a unique talent for solving some tricky engineering problems. So, here's our game plan for today. We're going to start with the big picture, just to get everyone on the same page. Then we'll open our toolbox and look at three special devices: the IC Synchro, the step transmission system, and the resolver. And to make sure it all really sinks in, we'll wrap up with a quick recap and a couple of practice questions. So let's kick things off with a fundamental question. We know that synchros are awesome for sending angle information from point A to point B, but what happens when the job needs more muscle, more power? Or what if you're stuck in a situation where you don't have the typical AC power that synchros love? How do you solve that? Well, that's exactly where these special tools come in. Think of it like this. Your standard synchro is great, but it's not a one-size-fits-all solution. Today, we're going to look at one device that delivers way more force, or torque, another that can run on DC power when AC isn't around, and a third one that's basically a tiny electrical mathematician solving complex problems on the fly. First up in our toolbox is the IC Synchro. I like to call this one the heavy lifter, and you're about to see exactly why it's earned that nickname. So what is this thing? An ICI, or Interior Communication Synchro, is, for all intents and purposes, a synchro that's been built inside out. The key thing to remember is that its internal coils, the primary and secondary windings that create the magnetic fields, are swapped. It sounds like a small change, but it has a massive impact. And why do we care? Well, it all comes down to one word: torque. That's rotational force. By flipping the construction, the device can handle more electrical power. More power means a stronger magnetic field, and a stronger magnetic field means a much, much stronger turning force. This makes the IC Synchro perfect for jobs that need to move heavy loads that would just overwhelm a regular Synchro. Okay, now this diagram might look a little busy, but let's just focus on the main idea. See how it shows that reverse design? In a normal synchro, the main power coil is on the spinning part in the middle, the rotor. But here in the IC Synchro, that primary coil is on the stator, the stationary outside part. That's the secret sauce. That's what gives it all that extra muscle. And here's how they work in a system. Again, don't worry about all the tiny details, just get the big idea. You've got a transmitter and a receiver, just like a standard setup, but the really neat part is that how you wire them together actually changes how they behave. You can wire them to turn in the same direction, or you can wire them to turn in opposite directions. It gives you a ton of flexibility. All right, let's grab our second tool, the step transmission system. I call this one the off-grid operator because it's built to work where standard AC power just isn't an option. The definition is pretty much right there in the name. It's a system made of two main parts: a transmitter, which is basically a big rotary switch, and a receiver, which is a special kind of motor called a step motor. And its defining feature? It sends all its information using direct current, or DC power. So why is this so important? Well, think about it. Not every piece of equipment, especially on ships or in certain industrial settings, has easy access to AC power. This system is a super practical solution. It's tough, it's powerful, and it's relatively cheap, all while running on the DC power that they do have available. Okay, so let's see how this thing actually works. Look at the diagram. Over on the left, that's our transmitter, just a simple rotary switch. When you turn it, it sends DC voltage through the wires to very specific coils inside the motor on the right. When a coil gets energized, it becomes a magnet and pulls on that little iron bar in the middle, the armature, causing it to turn and line up. Let's break that down. In this first position, you can see the switch is sending power only to coil number 1. The armature, which is just a piece of soft iron, gets attracted to that magnetic field and snap. It lines right up with that coil. Pretty straightforward, right? But here's where it gets really clever. As the switch turns to the next position, it's now sending power to both coil 1 and coil 2 at the exact same time. So what happens? Well, the armature is pulled by two magnetic fields at once, so it settles right in the middle, halfway between them. And if the switch moves again to only power coil 2, the armature moves again. This is why it's called a step motor. It moves in these hard, distinct steps, not a smooth rotation. All right, on to our last and, frankly, most mind-bending tool, the resolver. I call this one the electrical mathematician because its whole purpose in life is to do complex math electrically. So what is it? A resolver looks a lot like a synchro. Same basic shape. But on the inside, it's a completely different beast. It's designed to give you electrical outputs that are directly related to the trigonometry of a right-angle triangle. Basically, you give it an angle, and it instantly spits out the sine and cosine of that angle. It's a trig calculator. And why is that a game changer? Speed. And it's continuous. Instead of having some slow mechanical computer or, heaven forbid, a person trying to do these calculations, a resolver does it instantly, and it's constantly updating the answer as the angle changes. This is absolutely essential for things like radar, navigation systems, and old-school analog computers that needed those real-time answers. A resolver usually does two main jobs, and they're pretty much opposites of each other. Over on the left, we have something called resolution. This is where you give the resolver a vector, think of it like an arrow with a length and a direction, and the resolver breaks it down into its horizontal and vertical pieces. On the right, we have the opposite, composition. You feed it the horizontal and vertical pieces, and it puts them back together, telling you the original arrow's length and angle. So it can either take things apart or put them together. Okay, we have officially covered our 3 specialty tools. Now, to make sure these ideas really stick, especially if you're studying for an exam, let's do a quick recap and a couple of practice questions to lock it all in. Okay, time for a rapid-fire review. Ready? The IC Synchro. That's our reversed synchro for more torque. Step transmission system. That's the DC-powered guy for step-by-step movement. The resolver, our electrical calculator for trig. And what are its 2 main jobs? Resolution, breaking a vector down, and composition, building a vector up. Got it? Awesome. All right, pop quiz. First question. What 2 characteristics make an IC Synchro different from a standard synchro? Take a second and think about it. And the answer is the direction its shaft can rotate, which you can reverse with wiring, and the amount of torque you can get out of it, which is way, way more. Okay, last one. Compare the power sources for a standard synchro and a step transmission system. What's the fundamental difference? The answer is all about the type of electricity. Standard synchros run on alternating current, AC, but our off-grid operator, the step transmission system, runs on direct current, DC. And that's a wrap on the Synchro's very special cousins. Thanks so much for tuning in.